Hi again, everybody. Bill Sky, the COBOL guy here, and we're going to continue our discussion of arrays or tables in COBOL. This time we're going to look at two-dimensional arrays. If you haven't seen the one-dimensional array video previous to this one, do it now and then come back to this one, because this isn't going to be a super long video. I'm going to assume you already watched that video. So let's just jump right into the code. All right, so let's go ahead and create another project. So I'm on Windows again. The process is pretty much the same on Linux. So let's go ahead and create a new project from my template. And we're going to call this Arrays 2D. And I'm using Genie, and I'm using a makefile to make it very, very simple to set this up. Okay, now, if you remember in the previous video, we used the occurs times syntax to create a single-dimensional array. But let's go ahead and create a multi-dimensional array, two-dimensional array. And the way we're going to do it is that you cannot create a two-dimensional array using 77 level data types. You must do it with an 01 and 05. So we're going to just say 01 here, and I'm going to say 2dim array. And you don't specify any kind of a data type on this or anything like that. You just specify the name of the array as an 01, and then as an 05. And let me make sure I made this mistake. Yes, okay. I wanted to make sure I was using spaces instead of tabs. So now we're going to have the first dimension defined. So I'm going to call this, I don't know, two-dimensional array rows. And we're going to say occurs 10 times index by, I don't know, TDA index 1 or row index. Let's say row index. Okay, so that's for the rows. That's for the first index or subscript, and then for the second one, we're going to say O5 two-dimensional array calls occurs 10 times index by TDA call index. And that's pretty much it. That is your array. Now, we haven't specified the data type, so we're going to go ahead and put another line here and say it's a pick. Let's just say usage is comp1. Or we could have done something a little bit different. We could have said pick 95 usage is binary for just a bunch of integers. And there's our array. That's simple. Now you might want to do something a little bit different. Instead of specifying 10 times, you might want to create some constants. So I'm going to do that here. I'm going to say 78. I don't know, let's call it row or num rows. Value 10. 78 num calls. Value 10. And instead of 10 down here, we're going to go ahead and change this to num rows. Instead of this 10, we're going to call this num calls. Okay, let's go ahead and build this for Windows. So I'm going to do the custom. And we've got some problems. Let's see, oh, I never set up the, oh, nope, look what I did. I put a period right here. So let's double check this. Oh, I see. Okay, so I see what I did wrong. So these two are the exact same data levels, TDA rows and TDA columns, when actually TDA column should be the level below that. And there it builds just fine. Okay, so that is the method to actually define the array, the two-dimensional array. Now you could even create a third dimension or a fourth dimension if you want, but we're not necessarily going to go through that. Okay, so let's go ahead and let us go to the procedure division. And let's do something with it. Let's fill up all of those values with, I don't know, the index times 1,000 or something. So I'm going to do a perform. And how many times, well, how big is it? Well, let's take a look. I'm going to say perform varying TDA row index from 1 by 1 until RDA row index is greater than num rows. And then we're going to say end perform. So that's for the row. Because remember, in a two-dimensional array or multi-dimensional array, you have to have multiple loops. You have to have nested loops. So we're going to go ahead and do that. So that's for the rows. And then inside of that, I'm going to say perform varying RDA call index from 1 by 1 until RDA call index is greater than num calls. And then we're going to put end perform there. And we're not going to put a period on that one. You only put a period on the outermost end perform. Okay, so let's put some data in there. Now I'm going to use the compute, which we haven't really talked about yet in this series. But I'm going to use the compute, which is much more like a C or C++ or Java way of computing values. I'm going to say compute TDA calls parenthesis, and I'm going to say RDA row index, comma, RDA call index is equal to, and I don't know, let's just say RDA row index times 1000 plus 2. I know, I'm just putting in some numbers. Okay. Let's save and build this. Okay, we got a problem. Let's find the problem. RDA row index. Oh, it wasn't RDA, was it? Oh, it was TDA. It was TDA. Not sure where I came up with RDA. Okay, that looks good. Want to make sure I got everything there. Okay, let's go ahead and build it again. Still have a problem. RDA row index. Oh, gotta put a T there. It's amazing how you look at this code and you're like, okay, it all looks right, but it really isn't. There we go. Now I'm going to run it just to make sure I don't nothing dies. Okay, so I didn't get any kind of an error message. It didn't show that a return code of minus 10 billion were there. Okay, so we just filled it up with some data. Now let's go ahead and print the data. So I'm just going to copy this and do the exact same thing. But instead of compute, I'm going to say display. And I'm going to say RDA or TDA row index. Let's put it in there correctly. So let's do the TDA row index, comma, TDA call index. Just to kind of get something put out there. All right, let's run it. All right, let's take a look at our data. Okay, so row 1, column 1 has a value of 1002. Row 2, or row 1, column 2, you can see right there, has a value of 1002. We could have done a little bit better with that, but you can see the values. So let's go ahead and change this a little bit. So let's say plus, I don't know, TDA call index, maybe. Let's see if that's good. That gives us a little bit. Now the reason I'm going through all this trouble is I want to make sure we actually do have different values. And it looks like it's correct. So there's 1001, 2, 3, 4, 5, 6, 7, 1008, 9, 10, 11. All right, very good. So that's our data. That is our row and columns. That's our two-dimensional array. Now you could create a three-dimensional array by simply saying 15, oh, wrong place. I could say 15 VA, I don't know, cells occurs num cells times index by PA cell index. So now we have a three-dimensional array. And let us make sure we put that in there, because I would like to build this to make sure this actually is valid. Okay, we got some errors, but we didn't get any errors on the actual definition. So this is a three-dimensional array because we specified the rows, the columns. I'm not sure what this means, the cells. We got an error right here because our procedure division was not processing it correctly. So you can have one dimension, as we showed in the previous video, two dimensions, even three dimensions. You can also specify data types here, or I should say structures. So I could say 20, full name, pick x32, 20, weight, pick 999, 20, age, pick 999. So I could do something like this. Let's go ahead and build that, make sure that the definition is okay. We have put a period at the end there. So as you can see right here, we can have a structure which is part of the array. In this case, a three-dimensional array. You could also do this with a two-dimensional array. Just as we did it with the one-dimensional array. Now you have to make sure you get your level numbers correct. Okay, looks good. Now one thing that you can do, I'm using Genie here to do the builds. One thing you can do if you want is you can just say make win using my template and it'll do it that way. Sometimes it's a lot faster. There's a lot more clicks on using Genie than there is on the command line. So that's a multi-dimensional array. We did a one-dimensional array in the previous video. This was a two-dimensional array. I showed you how you could do a three-dimensional array, the processing of it. In the procedure division would have a third perform varying loop inside nested inside of the first two, and since we used complex or structured data, you're going to process that data a little bit differently. Okay, so the next video we're going to do is we're going to do a video on special data types, and then we're going to jump out and play around with the screen section, show you some really cool things you can do for data entry screens and data display to the user. Hope to see you at our next video.